My name is Tom, and today I want to share with you an event-based paradigm for implementing music structure analysis evaluation metrics. Music structure analysis methods produce label segmentations. Several different metrics evaluating label segmentations are implemented in MR-Eval, the go-to evaluation toolkit for many MR tasks. However, MR-Eval does so by using a frame-based paradigm, where the segment labels are sampled with a uniform frame rate. We can do better than that with an event-based paradigm for implementing the same metrics. We propose event-based implementation for computing the pairwise frame clustering score, the V measure, and the L measure. We benchmark them against existing frame-based implementations in MR-Eval using real MSA outputs on the Salami dataset. I'll use the rest of this presentation to highlight how this is done with the V measure, as well as some benchmarking results. The V measure compares an estimated segmentation S hat against a reference S by looking at the conditional entropy between their labeling. The central object in calculating the conditional entropy, and thus the V measure, is the joint probability of the label co-occurrence. Currently in MR-Eval, this contingency table is built by sampling labels at a fixed frame rate. I'll illustrate the process here by building the contingency table for this example using a frame size of 0.2 seconds. The process involves iterating through all the time frames and logging the number of frames where any pairs of label could occur. However, we can also build a contingency table instead by directly logging the time duration for these co-occurrences, like so. This not only reduces the steps needed to build the table from the number of frames to the number of segments, but also ensures the obtained joint PMF is exact. For benchmarking our implementation, we use the two-level reference hierarchies provided by the Salami dataset. For estimates, we obtain the 12-level hierarchies produced by Solomon et al.'s 2021 method. When benchmarking flat segmentation metrics, we use the finest levels from the hierarchies, and for L measure, we use the full hierarchies. We use 5 different frame sizes for running the frame-based metrics, and all experiments are conducted on a 2021 MacBook Pro with Python 3.9 and MIR-Eval version 0.8.2. I'll highlight some findings from our benchmarking experiments here. The top figure compares the metric runtime when using the event-based implementation, shown in red, versus the frame-based ones, shown in gray. Notice the y-axis shows metric runtime on a log scale, and the x-axis shows the duration of the tracks. We can see here, for example, that for a 6-minute long track, the event-based implementation for L measure runs about 1,000 times faster than the frame-based L measure with the default 0.1 second frame size. While picking a coarser frame size does make the frame-based implementations faster, they do compromise in metric accuracy as expected. Their deviation from the event-based versions are shown in the bottom figure. While our experiments show that the overall metric deviations are small, mostly within 0.01, the frame-based PFC and L measure tends to underestimate their event-based versions on average, and the frame-based V measure tends to be an overestimator. In conclusion, we've shown the event-based implementations of common MSA metrics are faster and more accurate. These advantages directly support more scalable and sustainable research practices, and the core idea can be generalized to other tasks such as sound event detection. I hope to see you at the poster session for more in-depth discussion. Thank you.